Let's now look at whether we can write the redox reactions that were occurring in the test tube that we've just seen. As mentioned, we started off with the pale green coloured Fe2 positive ions. And we started off also by adding purple permanganate ions to the ion 2. As the reaction proceeded, the purple colour disappeared because it was being changed into a colourless species, the manganese 2 positive ion. We noticed as the reaction proceeded that the solution, as the permanganate disappeared, was becoming a pale yellow or straw yellow colour, indicating the presence of Fe3 positive ions. To balance half equations, the first thing we do is try to balance the metals first. In the top equation, we have one Fe on the left-hand side and one Fe on the right-hand side, and that's balanced. In the bottom equation, we have one Mn on the left-hand side, and we have one Mn on the right-hand side, and again, that's balanced. But on the bottom equation, we've got 4 oxygens and none on the right-hand side. To counter that, we add 4 water molecules to introduce 4 oxygens on the right-hand side. But in doing so, we've now introduced hydrogen on the right-hand side where we didn't have that over here on the left. To counter that, we add hydrogen ions. And we need to add 8 of them. The next step in the process is to balance for charge. Fe2 ions, to form Fe3 ions, must have lost an electron. On the bottom equation, we have a negative charge here and 8 positives. That makes a total charge of +7. On the right-hand side, we have +2. To balance the charge, we need to add 5 electrons to have 2+ on both sides. Of course, the bottom equation can't accept 5 electrons if the top equation only gives 1 away. To balance for that, we require 5 Fe2 ions, each to lose up an electron to form 5 Fe3 positive ions. Now let's do a cross-check. In the top equation, ion 2 has gone to ion 3, and it's lost electrons, indicating oxidation. Of course, you can't have oxidation if you don't have reduction. Well, we did learn earlier in the week that permanganate is a strong oxidizing agent, and that oxidizing agents are themselves reduced in a chemical reaction. And reduction is gain of electrons. And we notice here that we have the permanganate gaining electrons. So that is a reduction half equation. To write the overall equation, we end up with 5 lots of Fe2 positive ions, which was that pale green, reacting with the permanganate ion, which was purple in colour, and it actually was an acidified solution of permanganate that we added. We ended up with 5 lots of the Fe3 positive ions, which was the straw-coloured solution, manganese ions, which are colourless, and 4 water molecules. In TCE chemistry, we want you to get into good habits of making sure you write the subscripts in for each of the species, and that is our overall redox reaction. Again, as good revision, we should be able to trace the course of this reaction by looking at oxidation numbers, and we can do that briefly. Fe2 ions start off with an oxidation number of +2 and end up Fe3 positive ions, which is an oxidation number of +3. Of According to theory, an increase in oxidation number indicates oxidation. +2 to +3 is an increase in oxidation number. If we look at the manganese on the left-hand side, oxygen always has an oxidation number of -2. There are 4 of them. That's a total charge of -8. Manganese added to -8 gives a total charge of -1, so the manganese must be +7. On the right-hand side, the manganese ion is +2. Theory indicates that a decrease in oxidation number indicates reduction. And here we have the oxidation number of the Mn goes from +7 to +2, which is a decrease indicating reduction.